Example number 4, we're going to solve another rational equation here. A lot of factoring, a lot of cool hairiness going on around here. All right, great. As we learned from the previous examples, we want to first start by finding out what is our domain here. It's kind of going to show us what our excluded values are. So let's go ahead and actually first factor all these. Okay, so we'll start with t squared minus 2t minus 8. If I factor that guy, multiply to get negative 8, add to get negative 2, so that would be a t minus 4, and then a t plus 2. Let's see here. Yeah, that's all right. Okay, so let's just factor first here, and then we'll get into the values. Great, and then if I did my t squared plus 6t plus 8, if I factor that guy, that would be t plus 4, t plus 2 now. That would be the factor of that. And then if I factored t squared minus 16, that's t plus 4, t minus 4, a difference of 2 squares. Okay, so basically, if I kind of look at this here, I'm going to go ahead and just rewrite this in factor form so that we can better see what is going to be our common denominator, and so that would help us out as well. So actually, let's just first look at what is our domain, right? So if we say, well, what are these values of t's? Well, t right here is equal to 4, right? What makes it equal to 0? When t is 4 and when t is negative 2. So 4 and the negative 2. And then here is when t is negative 4 and negative 2. And then here is when t is plus or minus 4. So what are all of these values that t should not be equal to, right? Remember, because we're going to say that our domain is going to be all x values such that x is a real value where t is not equal to, well, it's not equal to plus or minus 4. Plus or minus 4, so that takes care of that 4 and that 4, but then also negative 2. Okay, and we always want to start with that. We always want to start with what numbers, values will make the denominator 0. And so that's why we set the denominators equal to 0, and we did that by factoring right now. Okay, and then if I set this equal to 0, t would be 4. If I set this equal to 0, then t would be negative 2, and I did that for all of them. And so this is what we know what the domain cannot be, so then when we get answers, we may have to check that there, okay? All right, so now I'm going to just rewrite this in factored form here, okay? So we have 2 over, and this right here is t minus 4, and then t plus 2. Okay, minus 4 over t plus 4 and t plus 2 is equal to 2 over t plus 4 times t minus 4. Okay, so all I've done is I've rewritten the exact same equation, just now written in factored form. And I want to show you now what is our common denominator. Well, if you kind of look here, so this one has a t minus 4. This one does not have a t minus 4, and this one does. So both of these right here has a t minus 4, which means that this needs a t minus 4. So that means I would need to multiply this one top and bottom by t minus 4. Okay, let's see. This one has a t plus 2. This one has a t plus 2, but this one does not. So that means I need to multiply this one top and bottom by t plus 2, t plus 2. Okay? And let's see here. This one has a t plus 4, t plus 2, and a t minus 4. So both of these are all in common. So what does this guy need that both of these guys have? Well, it needs a t plus 4, right? See, t plus 4, but this one does not have a t plus 4, so we need to multiply this one by t plus 4. Okay, so now we can clearly see what the common denominator is, because now that they each have that. Okay, so now for our next step, we can kind of skip, we're not going to skip, but basically, you know, from the previous two examples, I said, okay, take the lowest common denominator and multiply every term by that. We've kind of already done that by doing this step, and that is if we just now take our numerator, okay, if we take our numerator, that will be just fine now. Like, we don't have to multiply everything by t plus 4 times t minus 4 times t plus 2. You said, well, why not now? Well, that's because, see, look, they all have a common denominator. Like if I said 2x over 3 plus 1 over 3 equals 5x over 3, if they all have a common denominator, then that means that you can just say, oh, okay, well, 2x plus 1 equals 5x. Okay, like if these two are the exact same thing. So that's what we're kind of doing here. See how they all have the exact same denominator? Okay, so that means we could just almost cross it out or just ignore it. And now we just have the numerator. Okay, so that's what we're going to do right now. We're not even going to multiply everything by that common denominator. We're just going to use our numerator now. Okay, so 2 times t and 2 times 4. So that's 2t plus 8. And then right here, now check this out. This is a -4, by the way. So it's -4 times t and -4 times -4. Okay, so -4 times t is a -4t. And -4 times -4 is a positive 16. Okay, and that's equal to 2t plus 4. All right, great. So combining like terms here, 2t minus 4t gives us a negative 2t plus 8 and 16, 24, and I get 2t plus 4. Great, so let's just combine more terms here, or solve now. So I'm going to add 2t to both sides. So 2t, and so I have 24 equals 2t plus 4. Subtract 4 now on both sides, and I have 20 equals 2t. Divide by 2t on both sides, or just a 2, and I get t equals, let's see, what did I do here? Hold on here. This is my mistake right there. It should have been a 4t right there, right? 2t plus 2t is 4t. So let me just make that correction. Okay, there we go. So that means this will be a 4t. 4t divided by 4 on both sides, so t equals 5. Great, so if we go back up to our domain, that was fine, right? Because we just said that t cannot be plus or minus 4, and it can't be -2. So the question is now, is this still a solution? And it is always a good idea to plug this back in. You can plug 5 into this, and if I plug 5 back into here, I should get the left side is equivalent to the right side. And so I'm just going to use Desmos to show that right now. And I already graphed it right here. And basically, I know that this looks super funky right here, but basically all we're looking for is, does the two graphs intersect at x equals 5? Okay, and if I zoom in right here at 5, they most definitely do intersect at 5 right here. So that's what we wanted to see. And so we're good.